Hello everyone, let's go ahead and do our homework for chapter 21. Which one of the following is not a redox reaction? What you need to look at is if the oxidation number changes from going from reactants to the products at least one element. If it does change, that's a redox reaction. If the oxidation number does not change, that is not a redox reaction. Okay, so let's look at the first one. Hydrogen peroxide H2O2. Normally oxidation number with any compound is -2, but oxygen by itself O2 would be 0 with any compound oxygen -2, but oxygen with hydrogen peroxide H2O2, here oxidation number is -1 because hydrogen is +1. So there are two of those +2. So the oxygen need to be -2. There are two oxygens, so each one of the oxygen therefore will be -1. So hydrogen peroxide oxygen oxidation number -1, water oxygen oxidation number -2, and oxygen by itself 0. So the oxidation number for oxygen changes from -1 to -2 and 0. Oxygen is going to be the reducing agent as well as oxidizing agent, the hydrogen peroxide. So in oxygen undergoes oxidation and reduction both. So that is a redox reaction. The next one, aluminum hydroxide. So in this aluminum hydroxide, the way it is written, something is missing. What is missing here is it should be AlOH4. Aluminum hydroxide should be a -1 charge complex. That is missing here as a typo. And similarly for hydrogen, it should be 4H+. Hydrogen cannot exist as this H hydrogen atom, that is a very active, atomic bomb even right there, hydrogen by itself. So it has to be H+, or it should be H2. So here the plus sign is missing. Okay, now let's see what is the oxidation number for aluminum in aluminum hydroxide. I hope you guys remember, if you have a complex like this with a charge, the elements oxidation numbers when you add it up equals the charge of the complex. For example, aluminum oxidation number plus there are 4 oxygens plus the 4 hydrogen. Their oxidation numbers when you add it up should equal to the charge of the complex, which is -1. Let's say aluminum we don't know, that's what we're trying to find out, but oxygen is -2. So -2 times 4 is -8. Hydrogen oxidation number +1. So 4 times +1 is 4 equals 1, -1. So -8 plus 4 is -4 equals -1. So aluminum therefore oxidation number going to be +3. So aluminum here oxidation number +3. Oxygen -2, hydrogen +1, and again hydrogen +1 there, and aluminum here also aluminum 3. In water also hydrogen +1, oxygen -2. So in the statement B, the reaction B, none of the elements changed its oxidation number. So that is not a redox reaction. Okay, and we can look at the other complexes to see if there is at least one element changes its oxidation number. You may not need to look at all the atoms, but you can try to find out if there is at least one. Let's try this one. Oxygen O2 oxidation number is 0, and we do have oxygen in water. What is oxidation number of oxygen in water? -2. So oxygen changes from 0 to -2. At least one element changes oxidation number. So that is a redox reaction. Let's look at the next one. Hydrogen. By itself H2 oxidation number 0. Hydrogen in water, hydrogen with non-metals, it would be +1. So hydrogen changes from 0 to +1. So that is also then a redox reaction. And then let's look at the E, sodium by itself, oxidation number 0. We have sodium chloride here. Chloride is -1, sodium +1. So sodium changes its oxidation number 0 to +1. That's also a redox reaction. The one that not a redox reaction would be reaction B. Okay. Number 2, consider the reaction copper oxide, hydrogen, copper solid and water. In this reaction, which substances are the oxidant and reductant respectively? In other words, oxidant is the oxidizing agent, reductant is the reducing agent that we learn in the lecture. Okay, remember, reducing agent or the reductant is the one that is undergoing oxidation. Oxidant or the oxidizing agent is the one that undergoes reduction. Now let's see how the oxidation numbers changes. Copper oxide. We always go by the what we know. The oxygen with a compound, oxidation number is -2. If oxygen is -2, so then the copper has to be +2 because the compound is neutral. Copper +2, oxygen -2. Hydrogen 0 by itself. And copper here by itself 0. And hydrogen again +1, oxygen -2. So which ones are changing here? Copper going from +2 to 0. Right? +2 to 0. Has the oxidation number increased or decreased? Oxidation number decrease. How do oxidation number decrease? By gaining electrons. Right? By gaining electrons. If you gain electrons, what do you call that process? That is a reduction. So copper oxide becoming copper, going from +2 to 0, oxidation number decreases. Oxidation number decreases by taking electrons. Right? If you are taking electrons, remember oil rig, reduction is gain. By gaining electrons, so the reduction. So this one is undergoing reduction reaction. If it is undergoing reduction, this is the oxidant, meaning oxidizing agent. Copper oxide is the oxidant then. What about the hydrogen? Hydrogen goes from 0 to H2O, hydrogen +1. Oxidation number increases. Oxidation number increases by losing electrons, by loss of electron, oil. So then if it is a loss of electron, oxidation. So this process is oxidation. It loses electron going from 0 to +1. Oxidation, so then the hydrogen will become the reductant or the reducing agent, reductant. So copper oxide is the oxidant and hydrogen would be the reductant. Okay. Next one. Consider the following balanced redox reaction. Which of the following statements is true? Manganese does not change its oxidation number in this reaction. And then manganese is the reducing agent and is oxidized. Manganese, okay. All the choices are related to manganese. So then we have to look at what are the oxidation numbers of manganese in the reactant and the product. Reactant manganese is +2. And you look at where the manganese exists in the product MnO2. MnO2. It's a neutral compound. There is no charge. So then the individual charges of the elements equals 0. Manganese plus 2 oxygen. Each oxygen is -2. So -2 times +2 is -4. equals 0. So the manganese oxidation number is plus 4. Right? So manganese going from plus 2 to plus 4. What is that process? Oxidation, because oxidation number increases. That is the oxidation. So then the manganese is the reducing agent, because the oxidation, the species that is undergoing oxidation is the reducing agent. So manganese is the reducing agent and is oxidized. So which one is the correct statement? It should be manganese 2 plus is the reducing agent and is oxidized. Okay, that is the correct statement. And then the next one, when the following redox equation is balanced, with the smallest whole number coefficients, the coefficient for nitrogen dioxide will be. Okay, so we learn how to balance equation in acidic medium. So we have to refer to that. Let's see. We have to first identify the two half reactions. One is I2 goes to HiO3. HiO3. Right? So this is happening in the acidic medium. So you can see there is nitric acid. So what we normally do is we separate the proton part and we isolate the ions that is undergoing reaction. Iodic acid can be separated to H plus ions and IO3 minus. So we remove H plus and we take iodate, because this hydrogen comes from the acid. So we can add it later after we balance it. Okay, iodate. And then we're going to balance the both sides with the atoms. I2, IO3, there are 2 iodines, so you have to make it 2 right there. And then we have 3 oxygen on the right side. To balance the 3 oxygen, you're going to be adding 3 water molecules. And then now that we have 6 hydrogens, 2 times 3 is 6, you put 6 hydrogen on the other side, 6H plus. Now all the atoms are balanced. Now we need to balance the electrons. 3 water molecule, all water molecules are neutral. So the left side, no charge. On the right side, we have minus 2, 2 times minus 1, plus 6 positive. So it's plus 4. Going from 0 to plus 4. What is that? Is that oxidation or the reduction? That is going to be oxidation, because the number increases. Right? So if the number increases, what do we need to do? We need to remove electrons. How many electrons? Going from 0 to plus 4. So it is losing 4 electrons, isn't it? Minus 2. Okay, I think I did a little mistake over here. Okay, see, let's see. So when I was counting the oxygen, I did a little mistake. I only considered these 3, but actually we have 2 at the front. So 2 times 3 is 6. I should be doing 6 water instead of 3. Do you see the mistake I did? When I was balancing oxygen atoms, I only considered these 3, that is I have circled, but it is 2 IO3 minus. So 2 times 3 is 6. So this should be 6 water instead of 3 water. Okay, should be plus 6 water molecule. So that will make it 2 times 6, 12 hydrogen ions, right? That changes. Plus 12 hydrogen, 12H plus. Okay. Now let's look at the number of electrons needed. So still water is 0, iodine is 0, so 0 from this side, and for the other side we have minus 2 and plus 12. We'll make it minus 2 and plus 12 plus 10. It goes from 0 to plus 10 oxidation state. Oxidation number increase by losing electrons. So how many electrons? 0 to 10. So it should be then 10 electrons to the right side. Okay, that is the balance oxidation half cell. We have to do the same thing for the other one. Now let's look at the other one. We have nitric acid, HNO3. HNO3 goes to NO2. Just like we did for HiO3, we're going to remove the hydrogen because it comes as the acid. We just isolate the anion. Nitrate goes to NO2. One nitrogen, balance. 3 oxygen, 2 oxygen. So you need to put 1 water molecule this side. And then for that 1 molecule, we added 2 hydrogen, so that will make it 2H plus. Now everything, all the atoms are balanced. We have to balance our electrons. So plus 2 minus 1 equals plus 1. So the charge is going from plus 1 to 0. NO2 0, water 0. Plus 1 goes to 0, meaning gaining an electron will become plus 1. So the number of electrons, 1 electron to the left. Now we have both half cells, right? We can add them together to get the complete balanced equation. So we want to make sure our electrons are equal. There is 1, there is 10. So what do we need to do? We need to multiply this by 10. So when you multiply, that would become 20 hydrogen, right? And we're going to be adding this and the other equation after multiplying by 10. So we have 6 water plus I2 plus 2 times 10, 20H plus 10 NO3 minus, and then plus 10 electrons. That 10 electron, this 10 electron cancel, and our products we have NO2. How many NO2s? 10 NO2s. 10 times NO2 plus 10 water molecules plus 2 iodate plus 12H plus. Okay. Here you have 20H plus, here you have 12H plus. So 20 minus 12 is 8. So we can remove this 12 and remove this 20. 20 minus 12 is 8. So you can put 8H plus. And then here you have 6 water molecule. And here you have 10 water molecules. Where did you go? Ten water molecule right here. 10 water molecules. So 6 water, 10 water molecule. We can make that 4 water molecules. Four water molecules, right? And now it's balance equation. It's asking what is the coefficient for nitrogen dioxide. So then this is nitrogen dioxide and we came up with number 10 at the front after we balance it. So your answer going to be then 10, the coefficient for nitrogen. So do this balancing yourself also and see if you also can get 10. Okay. Number 5. When the following redox equation is balanced with smallest whole number, coefficient for zinc will be, let's see here. So here zinc goes to zinc 2 plus. It's balanced, zinc and zinc. We need to balance number of electrons. So this is 0, 2 plus. By releasing 2 electrons, it would become zinc 2 plus. The other one, ReO4, goes to Re, rhenium, I believe, right? So rhenium is balanced. There are 4 oxygens, so you put 4 water molecules this side. And then 2 times 4, 8H plus. You put 8H plus, right? And then let's count the number of electrons. So the total number of charge on the left side 8, and this is 0, this is 0, this side is 0. Plus 8 goes to 0. Oxidation or reduction? Reduction. Gaining, right? How many electrons? 8 electrons by gaining 8 electrons. Eight electrons plus, right? So zinc 2 and the second equation has 8 electrons. So we need to multiply this by 4. When you multiply that by 4, it would become 4 zinc 2 plus 8 electrons. And then when we add these two together, 8 electrons get cancelled. And then we will end up having zinc, coefficient for zinc as 4. So do we have 4? So you can choose, none of these choices are correct. But I changed that in our homework credit. I removed this 4 and made it 4. So you will have a correct choice to choose in the homework credit sheet. So choose number 4. Not none of these choices are correct. I removed 7 and put 4 right there. So you can choose 4. Okay. All right. The next one. Consider the following redox reaction. Okay. When the following redox equation is happening in basic solution, balance with smallest whole number coefficient, what is the coefficient for hydroxide? And on which side of the equation hydroxide present? Now this reaction happening in a basic medium. So we need to see the coefficient for the hydroxide. Okay, let's see. Manganese hydroxide goes to manganese oxide and manganese permanganate ion. Okay, so we can choose these two. Manganese hydroxide. So in this one we take just the manganese only. Hydroxide is -2 or -1. There are 2 of those, so it will make it -2. So manganese is going to be +2. Just isolating just the manganese sign. Mn +2 goes to MnO4 -2. So you can try to balance this. There are 4 oxygens. You put 4 hydroxide. 4 hydroxide. So not hydroxide. We're going to be putting water. Sorry. We put hydroxide later. Mn +2. So for the 4 oxygen, we put 4 water molecules. And then to balance hydrogens, 2 times 4, 8H plus. Now let's see, plus 2 is the charge of this side, minus 2 plus 8 equals plus 6. Plus 2 to plus 6 goes by losing 4 electrons. Correct? So we're going to be adding 4 electrons to the right. That's one reaction. That is the oxidation. And then you have MnO4. Again goes to MnO4 minus 2. And this case, same number of manganese, same number of oxygen. But the charges are different, going from 0 to minus 2. Number decreases, reduction. So by gaining 2 electrons. So there are 4 electrons here, 2 here. So we need to multiply this by 2. When you multiply that by 2, that will give us 2 MnO4 plus 4 electron, 2 MnO4 minus 2. Now we can add the 2 together. 4 electron cancel. We have Mn plus 2 plus 4 water plus 2 MnO4 giving you MnO4 minus 2. MnO4 minus 2, there is 1 there. 2 MnO4 minus 2, 2 there. So 2 plus 1, 3. 3 MnO4 minus 2. Anything else? Plus 8H plus. 8H plus. Now this reaction is happening in basic medium. Remember, we learn how after you balance with the acid like this, if it is happening in a basic medium, to make the basic medium, you add the same number of hydrogen ions as the same number of hydroxide ion. So 8H plus, you add 8 hydroxide into both sides, 8OH, and then you add 8OH to this side also. So 8H plus and 8OH here makes 8 water molecules. Okay, so then the right side you have 8 water molecules, left side you have 4. So then you can get rid of this 4 and make this 8 minus 4 is 4. So that will make it 4 water molecules. So then the overall reaction, you would end up having 4 water molecules here. Now, after we balance, we end up having 8 hydroxides, right? But remember, manganese also comes as a hydroxide in our given reaction. So you have to give 2 hydroxide for the manganese hydroxide out of this 8OH. So this would become them MnOH2. So 2 was given for this manganese ion. So then 8 minus 2, how many left? 8 hydroxide minus the 2 hydroxide we gave for manganese hydroxide. That will end up having 6 hydroxide. So the answer going to be then 6 hydroxide ions in the left side, in the reactant side. 6 in the reactant side. We are doing question number 6. So the correct answer therefore would be 6 hydroxide in the reactant side. Okay. Again, try to do this balancing yourself after you learn how to do it, just to get practice. Okay. Okay, so the next one. Number 7. Which of the following could be used to construct a single redox electrode, have an element in common but in different oxidation states. Now let's see. H plus and OH minus. Hydrogen oxidation number +1. In hydroxide also hydrogen oxidation number +1. So we cannot use that. Same thing here. In water also hydrogen +1 and H plus. MnO2. In MnO2, what's the oxidation number for oxygen? Yes. So MnO2, oxidation number 0, manganese, plus the 2 oxygen, oxidation number equals 0. Oxygen oxidation number -2. So 2 times -2 is -4, manganese. So then the manganese oxidation number is +4. So it goes from manganese being +4 to +2. So here we have 2 oxidation numbers, so we can use that. And HCl and Cl minus, chloride is -1 and HCl also chloride -1. So you cannot use that. Fe3 plus Fe2O3. What's the oxidation number in oxidation number of Fe in Fe2O3? Fe2O3. Overall oxidation number 0. There are 2 Fe and 3 oxygen. The oxidation number 0. So oxygen -2. 3 times 2, -6. So 2F going to be +6. So the fluoride oxidation number +3 in iron oxide. +3, +3. It didn't change, so that cannot be used either. Okay, so we have the answer right there. I just told you. Manganese oxide going from +4 to +2. The next one. Which one of the following statement about electrochemical cells is correct? In a salt bridge, current is carried by cations moving towards the anode and anions towards the cathode. Oxidation occurs at the cathode in an electrolytic cell. Is that correct? Oxidation occurs at the cathode? No, oxidation occurs at the anode. In the external wire, electrons travel from cathode to anode. That's not correct either. It's from anode to cathode. Anode of a Voltaic cell is labeled -. Is that correct? Yes. Anode is where the electrons are generated. So it is labeled as negative. That's correct. So the correct answer is D. Which of the following solid is commonly used as an inactive electrode in electrochemical cells? We talk about that in the lecture, so you can find out the answer. And Voltaic cell is prepared using copper and silver. Its cell notation is shown below. Which of the following processes occurs at the cathode? We talk about that when you are writing, this is a cell notation. Always you write first what's happening in the anode, and this is what's happening at the cathode. It's asking which of the following occurs at the cathode. What is happening as it is written in the cell notation. So Ag plus goes to silver. That is the reduction. So reduction, Ag plus goes to Ag. This is 0. Oxidation number decreases. Reduction, which is the loss of electrons. Sorry, reduction is gaining of electrons. Oxidation, oil rig, reduction is gain. So you take 1 electron, go from +1 to 0. So you choose the one that represent this process. Ag +1 electron going to Ag solid, silver solid. The next one, the cell notation is given. Which of the following occurs at the anode? What's happening? So in the cell notation, the first process is what is happening in the anode. So anode here is aluminum to aluminum 3+, solid to aqueous. Oxidation number increases from 0 to 3+ by losing electrons, 3 electrons. So this is what's happening at the anode. So you choose the one that is appropriate like this. Okay. And then the number 12. Voltaic cell prepared using aluminum nickel has the following cell notation. Which of the following represent correctly balanced spontaneous reaction? Okay. You have to now separate the two equations, two half cells. First one is the oxidation going from aluminum to aluminum 3 plus losing 3 electrons. Right? Aluminum 0 to aluminum 3 plus, the way it is given. And then the second one, which is the reduction going from nickel 2 plus to nickel. You need to figure out the number of electrons, 2 plus to nickel 0, by gaining 2 electrons. 2 here, 3 here. We need to balance the equation, multiplying this by 2, multiplying this by this whole equation by 3. So the first one will become 2 aluminum 3 plus 6 electrons. Second one will become 3 nickel 2 plus 6 electrons 3 nickel. You can add the two together after you multiply. And then electrons, 6 electrons will be cancelled and you will get your balanced equation, and then you can choose the correct one. Number 13, the line notation indicates that, okay. First one, this is the oxidation and this is the second one is the reduction. Aluminum 3 plus is the reducing agent. Aluminum, when you write this equation, you cannot say aluminum 3 plus because aluminum 3 plus is going to be a product. So we cannot use that. Aluminum is the reducing agent. That means this guy here. So this is the oxidation. The first one that is written is the oxidation. Aluminum is undergoing oxidation. That's what happening at the anode. The species that is undergoing oxidation is the reducing agent. So B is the correct answer. Aluminum metal is the cathode. No, aluminum metal is the anode. Cobalt 2 plus ions are oxidized. No, cobalt 2 plus ions are going to be reduced because it's going from 2 plus to 0. Cobalt is the reducing agent. This guy. No, that's not correct either because that's going to be the product. So the reducing agent or the oxidizing agent has to come from the reactant side. Number 14. A Voltaic cell can be prepared from copper and tin. What is the E0 cell for the cell that forms from the following half reaction?